We talked about kind of a grab bag of topics. Richard had a bunch of questions about the so this idea that projects wouldn't have to have websites anymore, and kind of the question of where do users go for help if that's the case, and where do they go for information about the projects. So some questions were asked. I don't think they were not necessarily answered. We discussed an idea from Stefan having to do with how BOINC can use resources other than the ones that the BOINC client directly knows about. So for example, FPGAs or other computing accelerators, or sensors like weather or radioactivity sensors, earthquake sensors, and so forth. So there's this idea of having an extensible framework for describing these additional resources. Extensible in the sense that they're not sort of baked into the BOINC client; they're implemented outside of that, and that the way that these resources are communicated to the client could either be through GUI RPCs, particularly in the case where the state of the resources changes over time, or potentially just in a configuration file. And the idea is that the resources would be communicated to project servers with some kind of opaque XML structure, and that there would be the plan class mechanism would have a way of saying that a particular app version requires, let's say, a particular FPGA, or FPGA together with software that's running in it. It was pointed out that this is related to the Condor class adds, which is a kind of a generic way of specifying requirements for jobs in the Condor system. Stefan's use case was the optimal Golem ruler project. I don't remember the name of that project, but he has an FPGA version of the app that runs hundreds or thousands of times faster than the CPU version. And there were, and we talked about the ramifications of that, like the fact that the BOINC client kind of does have to know about the resource in terms of scheduling if there's a limit on the number of jobs that can use an FPGA at the same time, for example. Then we moved on to discussing support for peer-to-peer communication, in particular for parallel distributed applications, possibly like distributed machine learning, but really there could be a broad range of applications that use multiple hosts at the same time, communicating with each other, communicating directly peer-to-peer. Kevin had done some research and found a library called P2Plib, and then there's the question of whether that library would be part of the client or whether it would just be built into applications. And then I pointed out the kind of higher level requirement of being able to get your application running simultaneously in a large number of hosts, and knowing where those hosts are so that they can set up communication with each other. And that sort of segued into a discussion of for low latency computing, which is sort of the similar idea that where you can say, I want this job to run right away, and the scheduling mechanisms that would have to support that. There's already something in the server that lets you give a priority to jobs, and that controls the order in which jobs are sent. And then there's but then there's also scheduling in the client, which can delay the starting of a job. And right now there's a feature called delay bound, where you can say what time a job finishes by, but that is not really adequate for supporting this idea of low latency computing. So there's kind of a package of things that that we would need to add both in the clients and the server to support this idea of distributed computing with peer-to-peer communication. And I think that is something that would be worth doing and worth thinking about. Then the final thing we talked about is, we talked a little bit about this idea of an application library. The NanoHub already pretty much does something like this with their suite of tools. And they use a system called Rapture, in which there's an XML description of these tools that describes their inputs, the different command line parameters, the different input files. Each one can have, you can specify the type of it and the range of legal values. And from that, you can automatically generate web interfaces for submitting jobs, for submitting batches of jobs to those applications. And then we briefly discussed the question of whether if we want to have a library of BOINC applications, who's going to do the work of maintaining it, of tracking down the source code, building versions for different platforms, and so forth. And it was pointed out that that in the past, volunteers have done significant work in this area. For example, with SETI at Home, when we added support for GPUs, a huge amount of work was done by volunteers, some of whom are at this workshop, of porting SETI at Home to Cal and CUDA. I don't really, and I think OpenCL as well. And we had kind of a framework for vetting and testing those submissions. So I think the idea is that we can, in fact, distribute the work of maintaining an app library to some extent. And then the hour abruptly ended, and that's where we were.
Great. Well, thanks. Yeah, ours felt like it abruptly ended too, and I'm realizing now that we're actually a couple minutes ahead of schedule. But hopefully we'll all be able to continue these discussions in the weeks and months to come.